All right. So, chapter 10, then we're testing after the week after Easter. Okay. In 2 weeks, we will not have a class in either the 020 or the 120 because that's a big holiday. That's my birthday in 2 weeks. So we're not going to be here. Actually, it's also the Easter Thursday.
Happy early birthday then.
Early birthday. Thank you. So we're not going to be here. So after we come back from that, though, we're in testing mode because everything is going to be finished before then. All right. And I wanted to go back to that problem we were looking at because this problem that I was looking at in that textbook is one of the things that we covered last time. All right. And then after we look at that a bit, we're going to come back to 10.6, which is this odds and expectations. So I'm trying to use both the 020 and this class to go over stuff and reinforce things that we effectively covered in the lecture for the 120, just to give us some extra support. All right, so let's go back over here to that textbook. Oh, and when I exited out, he got rid of everything too, so I'm just go back through it. So that's no big deal because I needed to do that anyway. All right, so let me share the screen. All right. So this right here, the first thing I'm going to look at today, I mean, in the 120, is I'm just going to do a recap of 10.5. All right. $10.5 it is, one of the most complicated things so far. So I want to spend some time on this, extra time. So what we got here in the 20.5 recap, we got a student faculty government committee of 4 people. So we're going to form a committee with 4 people. There's no mention of order because it's just a committee. No president, vice president, or secretary. So this is not permutation, it's combinations. And it's going to be formed from going to be formed from 4 people. All right. And then this 20 and this 5 are going to combine to be 25. And so R is equal to 4, N is equal to 25. And those values are going to make up the denominator for all of these. So in other words, let's see where I can put this at. All right, and then I'm going to come in and write that in there. All right, so okay, so that's the I'm sorry, it's combinations. What am I thinking? So C 25, picking 4. And this is using the calculator. We'll do it. So 25 C, oops. C4 is 1,000. Okay. 12,000. So this right here so C 25.4 is the value right here. So that's going to be the denominator for all of these problems. So far, in everything we've looked at, the probability denominator is the total number in the sample space. And that's always going to be the case. It's just that it's one section, 10.8, we'll have to make an adjustment based upon certain conditions. But this right here is our denominator for all of these problems. So let's take a look at these. If this is our denominator, so we got to just figure out the numerator for all of these, and then we'll calculate the probability. All right. So that first one, that's telling us what to do for the numerator. We need all of our faculty members, all of our committee members to be faculty members. In other words, it's going to be here, C, and we're picking our 4. We're picking our 4. How many faculty volunteers are there? There are 5. So that part right there is the numerator. The denominator is the 12,650. All right, so let's go back to the calculator and figure out that numerator. I think I already did it. I know. Let's do it again. So it's going to be 5C4 because we're picking our 4 and we want them to come from all faculty members. And all faculty members, there's 5 of those. So that's going to be 5. And there's the denominator. We already decided about that. So then this is going to be 5 divided by 1,2,650. So we're going to round off to the third decimal place. 1, 2, 3. So we're rounding off to 1, 2, 3, fourth decimal place. Because that's the first one we can. If you ran it off to any other ones, it would be 0. So this is going to be 4 because the one right next to it, immediately to the right, is 9. So it bumps the 3 up to a 4. All right. Second one, we want 2 students and 2 faculty members. Therefore, there's 2 of them are coming out of the 20 and 5, 2 of them are coming out of 5. So on this one, it's going to be 2 taken from the 20. This is the student part. And then we got and, so we're going to multiply those 2 in the numerator. And this one is going to be 2 taken from 5. And so down here is I was trying to write small so I could get everything in, but I'm going to have to come down anyway because I'm already taking up the space for the third problem. Okay. So I'm going to do the numerator in the calculator. And the good thing about the ALEKS calculator is that it's letting us do that. So let's put 20 C2 there. And then I'm going to hit the division and I'm going to put the 1,2,650 by there now, but I'm going to go back up because I needed to create the fraction. So, because if you put the whole thing in first, unless you use parentheses, it's going to only divide by it's going to divide the second one. So this is 5C2. too. I'll tell you what. Let me do that part, and then we'll come back and divide it by. So that's 1900. Divided by 12650. So then what is that? What happened? What? 1900. There we go. So we're going to go out to the same one to right here. So this is going to be a 2 now because the one immediately to the right of it is 9. So 1502. All right. So I'm rounding these off to the 4th decimal places, all of them. All right. So the all students, I'm going to put that over here. All students is very much like the all faculty members, except in the numerator, all we're going to have is N20 or 5. So over here for C. So I'm going to put a C. And then we're doing the 4 being picked from the 20 students. And again, this has got that same denominator down there. All right. And that's a 20. Let's see if I can make that a little bit better. So 4 from 20. All right, so let's do that on the calculator. Wherever that calculator is hiding, it's down here. So I'll put the calculator over here. So again, now we got 20. These are the number of students. We're doing combinations because we're not worried about order. And we're picking 4. So this is going to be 4, 8, 4, 5. And so it's all over the 12,650. All right, so let's divide to get the final answer. What in the world is it doing that for? It did that before. I must be assuming since it's in there that it's going to let me just divide, but it might not be reading it right. So there we're going to go out to 4th decimal place. And so it's just going to be 0.3830. All right. So the last one I'll do back on the right side. All right. So now we got an and. And when we have an and, like we did up here, see, we multiplied. So what we're going to do is we got to do the faculty side and we got to do the student side. All right. So the faculty side is going to be first. I'm going to put a couple of C's here. And then at the bottom, I'll come and put the numbers there in a second. All right. So one faculty member is being picked and 3 students are being picked. And you remember, that our denominator is going to be the C the same one that we had up here, the C25. All right. So y'all still out there?
Yes.
Yes.
Okay.
I'm here.
All right, good. Now we're picking from, for the faculty side, see, that's faculty. So we want the one faculty is right here, and we're picking from, it was 5 faculty. All right, remember 5 faculty. And then there's 20 students. Okay. So that's the setup of it. Now let me explain something to you in case you don't see this pattern. But because this is the key, when you got these, when you got 2 of them like that are multiplied, when you get an and, five plus 20 is 25. 1 plus 3 is 4. See, they match. You're breaking them into 2 based upon the criteria which you're looking for. So now we're going to equal out here. Let me get to blue. I thought So remember, the denominator was the 1, 2, 650. And then we'll do the separate ones up here, and then we'll do it in calculate. We'll do it, use the calculator to do each of the permutations, and I'll write them in there. So we're going to put 5C1. So that's going to be 5 times, and then the 20C4. C3, I'm sorry. So 1140. Oh, I'm sorry. It's just 1147. All right, so it's 1,000. The comma goes right there. All right, so I'm gonna do it all thing on the calculator. Well, let's see. I'll tell you what. So 5 times 1140. So that should be 5,700 up top. And then I'm going to do it with the calculator as well so we can check. Okay. So as I said, is on the calculator, we're putting in the 5C1. So that's the 5. You know what? I already did that. So I'm just going to do the multiplication so we know what it is. Let's check and see if it's. And that's the 5,700. So we got that right. And then down here, put in a few little symbols. And so what is that? Let's see if it do it without. And that's 0.45. So we're rounding after that 4 decimal places. So this is going to be 0.4506. And there we go. So again, that was a recap of 10.5. I wanted to go through this because you'll see a number of ones like this. Remember, for the and, you're multiplying in the numerator. The denominator for all of them will be how many you're picking from the total. That's how the 12,650, because that's 4 being picked for 25. That's what's being done blindly. And then each one of the questions then tells us what the specific numerator is going to be. Okay, so any questions about that problem?
No.
Okay.
All come together, all making more sense.
All right, good. This, like I said, is 10.5 is where it starts getting tough. So, and it'll get easier with chapter 11 generally, but 11 is kind of usually the toughest chapter for most folks. And as I said, also the exam for the O2O, for those people who are in the O2O, not everybody in here is in the O2O, will be the first 3 chapters, chapter 2, chapter 3, and chapter 10. All right, so let's get down to 10.6. All right, so 10.6 is odds and what's called expectation. So this is where we're at today. We'll probably finish everything even before this day here, but which is the Tuesday before the break. This is the 2 weeks from now, but I want to make sure we're going slow. So, but we will finish before that break. And then after we come back, we'll have kind of a work day to review everything. I'll go over that review and then the test. Okay. So what are odds? Does anybody know what odds are? They're related to probabilities, but they're not exactly the same
Numbers
thing.
that can't be divided into another number, right?
What's that? Say that again, Kendra.
Like 1, 3, 5. Numbers that's not even.
Okay. Now, well, all right. That's when we're talking about odds and even. Exactly. That's what that is. But odds are a cousin to probabilities. When we say odds, and I'll often see this. I can't remember where I read it yesterday. There was something where I was reading something that somebody had written. Oh, I know it was. It was in a class that I teach, and the student had even used the term probability when what they were given was odds. All right, so let me see if I can explain the difference. So if we look at this right here, oh, all right, just look at that little bag. How many marbles are in there? 1, 2, 3, 4,
6.
5, 6. There's 6 marbles in there. All right. So I'm going to write over here, probability of red in that first bag is equal to, all right. There's 2 red, right, in that bag. And there's 6 in the total bag. So 2 out of the 6 are red. And that simplifies down to 1/3. So this is the probability of red is 1/3. All right. That's the probability. But odds is slightly different. Odds tells us the relationship to what's red and what's not red. See up here? All right. Now, I'm going to write over here a little bit of explanation. How do they get 1 to 2? All right. So that's going to be 2 reds, right? 2, 4 blue, or 4 not red, actually. We're not talking about the color for the other ones. So there are 2 red and 2 and 4 not red. Now, in the same way that we simplify the fraction, see, we got the 2/6 simplified to 1/3. Well, if we divide both the 2 and the 4 by 2, we get 1 to 2.
Oh.
And that's where this, oops.
Yeah, put it 20.
Yeah, I know. And it's everything. So it was 2 to 4. So 2 is red, 4 not red. And then when we simplify it, it's 1 to 2. In other words, both the 2 and the 4 are divisible by 2, which is how we get the 1 to 2. Because we always want to work with simplified odds, just like we work with simplified probabilities. So odds just tell us a different story. It tells us the relationship in the bag of red to blue. For every 1 red, there are 2 blue marbles. That's what odds are doing. They're telling you the relationship between whatever it is you're looking at. In this case, we're looking at red marbles to not red marbles. All right, there are two kinds of odds. And this is important. There are two kinds of odds. The one that's most often used in gambling are odds against.
Almost
Odds
said that's
against.
how you get paid out on a bet when you ask what odds are, but I didn't want to sound like that guy.
Yeah, in a sense, it will tell you that kind of what a payoff. So for every $1 you bet, you know, you would get 2. But here's the thing we got to worry about odds against. When we're talking about odds against, it's different than this. All right. On this one, we were talking about odds of red. So we put the number of red first and the number not red second. All right. But odds against is the number of not is first, the number that are second. And the reason why I think this happens with odds in gambling is just because it makes it look more attractive if you have the bigger number first. All right, so the other odds is like the one that was up here. This is odds in favor of an event. Odds in favor is just flip them around from this. Now, odds against is written as B to A. We call that first one B when we got odds against. When it's odds in favor, they're just turned around. They're just essentially the reciprocal of one another. All right, just turned around. And the A goes first with odds in favor. So the A, in the case of this one up here, was the number of red, the 1, and the ones that were not red, the 2, the B. So let's put these into practice, and then we'll see if we can make it a little bit more understandable. Now, we got to remember this. We need to know this in order to fool with odds. We got to have the complement rule. And the complement rule was the probability of A, and that's just any event, plus the probability of not A is equal to 1. All right. And we also looked at it sort of like this, the probability, you could rewrite it as such. And if you've done your 10.1 stuff, you were fooling with this over there. All right. So that's the complement rule. And that's what we're going to use here. All right. Because we need to know the probability of both of these things. So here's the one I want to look at now. If the probability of a horse winning is 1/12, then find the odds against. All right, odds against. So this is going to be B to A is what this is.
That'll be 12/1. You say flip it?
No, you're not flipping the right thing. We can't flip it until we know what the odds are. We don't know what the odds are.
All right.
We're looking for this right here, A to B. I mean, B to A.
B to
B
A.
to A. Because you remember up here, as we said, B to A is odds against. There's several processes here. We're not ready to do that reciprocal thing yet. And matter of fact, we don't really need to do that in the first two. There's one down here in that second way we can do it. Because we're just doing one odd here. We're doing the odds against, and then the other one's odds in favor. And they're different problems. So the probability of a win, I'm going to put win for horse winning, is equal to 1 I'm going to write out because you just can't write fractions linearly like that. So using the complement rule, what is the probability of not W? This is why we need that complement rule. And I'm going to show you an easy way to do this without having to go through and do the fraction and all that. Well, you still got to have this fraction. But what I'm saying is the way that Alex explains it, they will go through a bunch of rigmarole that you really just makes it more complicated, in my opinion. But let me ask you this question. If we take 1 and subtract from 12, how many do we have?
11.
1 from 12 is 11. And then we keep our same denominator.
Ah,
So 1 from 12 is 11. So the probability of not winning is 11 twelfths. So this right here is our A. And this right here is our B. We're not worried about the 12 at the bottom. So A is 1. Maybe I will just do this instead. So A is the numerator of the winning. B is 11. All right, now we're going to put these together. But notice that we didn't use the denominator, we just used the numerator. But what happens if you add 1 and 11? You get back your 12. So we're not losing that. It's just that for the odds, we don't need it. All right. When we get down here, when we go back to from odds to probability, we can simply add those two and get our denominator back. So now odds against is 11 to 1. So keep in mind that the probability of this horse is 1/12. In other words, 1 out of 12. It's only going to win 1 race out of 12 races. It's going to lose 11 times out of 12. But this is my theory about why gambling uses odds, because 11 to 1 sounds a lot better than 1 to 11. I don't know if that's true, but that's what I think. All right, see how that works? We just found the probabilities, and we took the numerators, and we took those numerators and arranged them according to which odds we were looking for, odds against. So the B was 11, so that comes first. The A was 1, that comes second. All right, now we're going to find out slightly different. The probability of getting an A is 3/13. And now we want to find odds in favor of getting an A. So this is going to be here. This will be the form of what we want is A to B now, because that's odds in favor. All right. So now we got to do the same thing we did over here with our probabilities. We got to find the probability of getting not getting an A. So the probability of an A is 3/13. So the probability of a not an A is what? Perform that same thing that we did up there. 3 from 12. I'm sorry, it's 13.
9, 10,
It's 13.
right?
So 3 from 13 is indeed 10. And we keep the same denominator. We don't really need the denominator to find the odds, but I'm just showing you that that's the complement rule in action. That we used my little favorite trick to find out the probability of not getting an A is simply 3 from 13 from the denominator gives us 10, and it's still over 13 for the probability. But we're not using the denominators now for the odds. So I'm just going to say A is equal to 3, B is equal to 10. All right. And we're looking for A to B, odds in favor. So that's going to be 3 to 10. And so you'll just notice now that the small number comes first. So out of 13 people, and we're just speculating here, this is just an example, that's been made up. But we got 13 people, 3 of them would get an A, 10 get no A. We don't know what they're going to get, but they're not going to get an A. So that's why the odds in favor of getting an A are 3 to 10. All right. Any questions about that? I'm going to go through that next one really quick because there's really only one thing to do.
You said small number first, right?
Well, it does not, it's not a matter of the small number. It's A to B for odds in favor, B to
Gotcha.
A for odds against.
Gotcha.
So in that particular case with the horse racing, 11 to 1 sounds a lot better than 1 to 11. That's why, like I said, is depending on what odds is, whether it's odds in favor or odds against, that tells you which one goes first.
Okay.
All right. So real quick, we've done this plenty of times. So the probability, we got a standard deck of cards, 52. We want to find the odds in favor of getting an ace. So probability ace is equal to 1/13. Remember that? Because it's 4 over 52, which simplifies down to 1/13 because out of every 13 cards, suit of cards, there's one ace. So probability of no ace is 1 from 13, so that's 12/13. So in this case, A is equal to 1, B is equal to 12. All right. So this is odds in favor. So this is going to be A to B, which is here 1 to 12. So now here's where your reciprocal comes in for this one here. odds against, it's the same event now. So now all we're going to do is take the reciprocal. So odds against is B to A. So then it's 12 to 1. And so just what these means, that just means that for every 13 cards you pull out of there, one of them is going to be an ace. That's all that means. One ace, 12 that are not aces. And they add up to 13. So let's do this real quick now for the, for some reason now I'm like running a bit behind what I was going to do. But we'll do these real quick. Now, for this over here, A is equal to, oops. So this is odds in favor here. So that means that it's A to B. So A is 9, B is equal to 2. So then we can find the probability that the mouse will be eaten. It's going to simply be A over A plus B so in this case, the A is 9. And then the A plus B is 9 plus 2. Let me put some punctuation in there to. So 9 to 11, 9 over 11. That's our probability of success. The probability that the mouse is eaten. 9/11. So we're going backwards now. So down here to my dice roll, the odds in favor of getting a sum of 9 are 1 to 8. So A plus B is equal to 1 plus 8, which is equal to 9. We've got odds in favor. So the 1 is our A. And then the 9 is going to be the denominator. So the odds and the probability of getting the dice is, I'm sorry, getting the sum of 9 is 1/9. Because A is 1, A plus B is 9. And that kind of is verified by the fact that when we did this earlier, whenever it was we did the things, we actually did one that had the sum of 9, and it was 1/9. So that confirms it. All right, so let's hit this other part real quick. Like I said, I don't know how I got a little bit behind. All right, so the expected value is a way to quantify the chance of a particular event and whether it's going to be a winning expedition or a losing expedition for a particular event. And it simply works like this. The expected value is just what the outcome is. That's what X is times the probability of that outcome. And however many scenarios you have with win and lose, you just add them up. Sometimes it'll be positive, sometimes it'll be negative. So let's go through this briefly. And then I'm going to go through one from scratch. All right, so if we have a game where you roll a die and then whatever rolls up on the die as far as the number of dips or whatever they call those dots, multiplied by the probability, that's going to tell us what the outcome is. So the outcome for the first one is 1, and there's 1 on there, so there's 1 out of 6. Each one of the probabilities is 1/6. That's why it's always the same, because there's 1 of each number on the die. And if we multiply it by that dollar amount, our outcome, it comes out to, see if I can do it on the calculator and show you. Because this calculator works real nice for this kind of stuff with fractions. So 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times, 5 times 1/6 plus 6 times 1/6. That's going to give us 3.5. So that's where that comes out. So if it's, to sum it up in a way, if we had a game that we could play like this and somebody was willing to lose money at it to let us play, we could expect to win $3.50 every time we play it. Now, it's not possible to win that on any particular roll of the die because you either win $1, $2, $3, $4, $5, or $6. But what this means, what the expected value means is, it means what happens if you do it continually over time. And this value, since it's positive, $3.50, means that it's a winning proposition. Now, in reality, anybody that's doing a game of any kind, and this could be used in things like insurance as well. Well, whoever's offering the product or offering the game or event, is they're going to be wanting to have a profit. So it's not always going to be positive, and usually it's not. All right, so let's see if I can do this real quick. All right, we got raffle tickets are sold for $5 each. 4 of the tickets will win $1,000, $500, $200, $100 cash. After that, you don't get anything. So there's only 4 tickets. All right, so right here is going to be the X, and right here is the probability of X. Okay. So now I'm going to put right here, this is the 1,000. This is the 500. And then this is the 200. This is the 100. So there's the 4 things that can happen, but there's one more thing that can happen. What can happen?
You can win 2,000.
What?
They can win 2,000 for.
They can win what?
They can 2,000 tickets or so. Okay, I'm sorry.
Right. But
You
what
can
is
win
the other
0.
thing that can happen besides winning 1,000, 500, 200, 100? It's something that people don't like to think about.
0.
Nothing.
Yeah. Well, you're gonna lose.
Yeah.
Oh,
All right. And that's essentially -5 because you're paying $5. All right. So here's where we have to watch out now. People don't often gamble and tell you what it cost. So what are we actually winning if we win the $1,000?
$9.95.
You get $9.95 because you're paying $5 a play. So the same thing here, $4.50. So $4.95, $1.95,
$5.95.
$95, And then just here is just -5. All right, so I'm taking that -5 away from each one of these because net winnings is important because we're not winning 1,000 if we had to pay to play. All right, now we're going to use now this $10,000 information. How are we going to use that? That's 2,000 tickets. 2,000 tickets. So with that in mind, what is the probability of winning that $1,000 prize if there's 2,000 tickets? How many winning tickets are there?
2,000.
How many winning tickets are there for $1,000?
Just one.
There's just one. Out of how many?
2,000.
So that's the probability of winning that one. And then all of these will be the same. Or all of the prize ones will be the same. 1 out of 2,000 because there's only one ticket of each.
There's 4 tickets. Okay. 1 ticket each. Okay.
So each of these has the same probability of being won. 1 out of 2,000. All right. For this last one, there's still 2,000 tickets. But how many losing tickets are there? If there's 4 winning tickets, how many losing tickets are there? 4
One.
winning tickets.
1,996.
Exactly. All right. All right. So now, remember with the thing, what we did, we just multiplied the outcome times the probability. So now I'm going to try to squeeze in here. And I might not have enough room, but I'll get it somehow. I know what I can do. I can take this rascal out for a minute. There we go. No, that's not going to help. Not as far as the. All right. So what I got to do is I got to multiply down. So I'm going to have down here. This is my X times P of X. So I'm going to multiply down. So 995 is a whole number. So when it multiplies 1/20th, I'm sorry, 1/2000, it's going to be 995 over 2,000. And I'm going to put it in the calculator in a second and show you because that calculator works nice for this. And then this is 495 times this. So this is 495 over 2,000. $195 times 1 over 2,000 is 195. So these are easy because there's a 1 in all the numerator. That was a 6 there. How did that go away? And then this is 95. Over 2,000. And you could do these as decimals if you wanted to. You could do this with the Alex count. I mean the TI, and do it as a decimal because it's going to be expressed as money. And for the TI, that one is the way to do it. So I'm going to just show you over here on the side how we get this. This is -5, and it's -5 over 1 times 1996 over 2000. So the 5 is going to be multiplying the 1996. And then we got 2000 in the bottom. All right. So this over here is going to be, let's see. So that's 5. Is going to be 9,998. But it's negative. Over 2,000. Now, this is not that bad of a fraction because it's all got the same denominator. So if we add all of the same denominator, we just got to add up the numerator. All right. So in the numerator, we got 995 plus 495 plus 195 plus 95. So we got here for the positive part, 1,780 over 2,000. So we're just going to put it all over 1 since they're all the same denominator. And in the numerator, we're minusing the 980. So that gives us 1,780 minus 9,980. So that's 8,200 negative. Let me bring it over a little bit so we get enough room. So we got one more step. So 8,200 over 2,000, and the sign of it is negative, which means that this is going to be a loss for the player. And you would think so, because whoever's running this game, they want to make money by selling these raffle tickets. So then this is negative 4.1, and I'm going to put a 0, because what this is, the expected value is for this. And I'm just going to write up here. Expected value, well, I'm just going to put EV is equal to negative $4.10. Now, what does that mean? I'll explain it to you, and then that's where we'll end at. But that negative means that the player is losing $4 on the average. Each player is losing $4.10. Therefore, the house, whoever's running this, if it's the church or some kind of group, every time somebody buys a raffle ticket, the house is gaining $4.10. Now, it's not possible to do that for just any one player, because you're either losing $5 or 4 lucky people are going to get one of those prizes. But on the average, $4.10 is the cost to play this game. And so the people running the game, they're expecting $4.10 for everybody, but it figures in paying out those costs for the prizes. All right, so I don't know how I got behind it because I don't hate to rush on the last problem, but I guess I must have put too much time with that first problem where I went over that 10.4. But anyway, we'll look at this next week a little bit in the O2O. And if you got any questions, bring them back next time. So I will see you on Tuesday.
See you Tuesday.
What did you say? Was that you, Jordan?
Oh yeah, I just said see you Tuesday.
Okay, bye-bye. I'm gonna stick around here for a little while, just make sure anybody doesn't need anything.
Good night.
Bye-bye.
Mr. Cruz?
Mm-hmm. What's up, Naomi?
Okay, so we're stopping right here.
Mm-hmm.
Okay. Alrighty,
That's
well,
pretty
thank
much
you.
all of 10.6.
Oh, yeah, I
Did you have a
can
question?
see. Okay.
Yeah, we pretty
No,
much done for the
I'm
night.
gonna try to, okay, I'll just, whatever, if I have a question, I'll just write it down when it comes to the homework
Yeah,
part.
that's fine.
Okay.
Send me
All
an
right,
email.
thank you. Okay, thank you so
Okay,
much. Have a
bye-bye.
great one. Bye-bye.
Okay, bye-bye.
Mr. Cruz, I had internet problem with that in-class assignment.
Mm-hmm.
Yeah. I saw it and record everything. But
So where
okay,
was you at? Where were you at Tuesday?
taking care of my 90-year-old grandmama. I had to go out
Oh,
of,
okay. I was wondering. I
yeah,
thought maybe you something had happened to you.
yeah, I had to come to Mississippi. I'm still here. So,
All
but
right.
I'll be back in New Orleans by some Saturday.
Oh, were you out of town?
Yes, sir.
Okay.
I have a 90-year-old grandmama still alone, so I come down here to
Why you got
get some
such a
stuff
young
in order.
grandma? I got a 90-year-old mom. I mean, I got a 94-year-old mom.
Yeah, and she's feisty. She in there sweeping because
Yeah,
you think
she's
she'll sit down somewhere, but she study keep going. I love it for her. I love it though. But I
that's
had to
good.
come down and see about her because she still stay by herself and stuff get a little overwhelming for her. Make sure she
Where is
taking
it
up
you at?
Pearl, Mississippi.
Where
3 hours.
Pearl?
Yes, ma'am.
Pearl,
Yes, sir.
Mississippi?
Yes.
Jackson?
Yes. Right
Over
outside of
Jackson. Okay.
here.
All right.
But I'm
All
trying
right.
to
Well, I just
stay.
want to make sure you were all right. So I sent you an email. I was wondering if something had maybe happened to you.
I know, yeah. I'm back focused. Like I'm gonna keep up.
Okay.
All right. Thank you.
All right. Bye-bye.
All right. Bye bye.
Anybody got any questions? Or is everybody's just in here for the fun of it? Otherwise, I'm going to end the session, go eat some more of my soup, special soup. All right. See y'all next week.